Hello again, Dr. Kevin Anderson here for Lesson 2 in Chemistry, Scientific Notation. Now this is a little bit quicker of a lesson, but it is very important. You have to be able to know how to convert into and out of scientific notation. You'll see it'll become very important when we move on to significant figures. So what is scientific notation? Scientific notation is a mathematical expression used to represent a decimal number between 1 and 10, multiplied by 10, so you can write large numbers using less digits. An example of scientific notation is when you write 4 times 10 to the power of 3 for 4,000. So the general form of scientific notation, as I have drawn down here, you're always going to have a ones digit, nothing more. In scientific notation, you may have things past the decimal, you may not. It could just be 3. In this case, it's 3.12. It'll always be in the form of times 10 to the power of some number. I have just y here. It can be any number, negative, positive, usually whole numbers. Okay, that is the general form of scientific notation. Now, how do we convert numbers to scientific notation? What is the rule? In general, if you move the decimal from right to left, well, let's do left to right. Left to right, the powers are going to decrease by that number of times you move it. So from left to right, the power decreases by the spaces you move. The best way is to show you how this works. So for example, if we have 0.000123, when you don't see it in scientific notation, we assume that to be to the power of 0. Anything to the power of 0 is 1. So how many places do we need to move the decimal? We move it 1, 2, 3, 4 places. Why 4? Because we need to have the ones digit in front of the decimal. So that means we would write it as 1.23. Since we moved it 4 to the right, 0 is going to decrease by 4 times. That would be times 10 to the minus 4. Again, 0 minus 4 is negative 4. That would be scientific notation for the first number. However, what if we move the decimal to the left? It's the exact opposite. Okay, so the rule is for moving it to the left, now you increase. Okay, it's the opposite, so it increases by that value. So in our case, we don't see a decimal. Again, we assume it's times 10 to the power of 0. How many places are we moving to the left? The decimal would have been here. It'd be 1, 2, 3, 4 to get to single ones digit in front of the decimal. So that would be 5.4321. If we moved 4 to the left, now you go 0, 1, 2, 3, 4 higher, and that would be 5.4321 times 10 to the power of 4. That is how you move into scientific notation if you're moving the decimal to the left. All right, you also need to know how to go the exact opposite way, converting numbers from scientific notation out. Okay, so now the rule is you're looking at the power. So if you see a negative power, that means you're going to move the decimal to the left. Okay, so let me write that rule. The rule is if a negative power, you move the number of spaces to that power to the left. So in this case, it's the decimal you're moving. So if we're power of negative 2, we start at the decimal and we need to move to the left 2. So it'll encompass the 7, and we move one more, and that's where the decimal will be. Any open space, you're going to go in there and draw a 0. So then you rewrite it out as scientific notation. It would be 0.0783. Okay. Likewise, what if we have a power that is positive? Okay. So this was the negative power. What if we have a positive power? Now you're going to move decimal to the right by that number. So the opposite direction. So again, if you don't see, well, we should have had the decimal here. So we're going to move it to the right 5 units. Now this is going to get a little bit messy, so I'm going to rewrite the 1.45. So we're going to move it to the right. Let me just get a different color. So 1, 2, 3, 4, 5. Put the decimal there. Any open space, you're going to draw a 0 in. 0, 0, 0. So when we write this number, you don't have to have the decimal in the number. Sometimes teachers have you put it, but it would be 145,000. And again, let's put a comma, so 145,000 would be the answer. So that's how you convert out of scientific notation. Again, I'm going to give you some homework to practice this on. If you have any trouble, just refer back to the rules that I showed you in the video here. Good luck, good day, and the next lesson that we're going to be working on is conversion factors, not just metric system, but converting all sorts of numbers using dimensional analysis. I look forward to teaching you that next. Have a great day. Thank you.